Its crew climbed aboard without ceremony, without drama, without the elaborate rituals that German tankers had come to accept as the price of winter warfare. That moment, that simple contrast between a machine that worked and a machine that did not, would force the Wehrmacht's finest engineers to confront an uncomfortable truth. They had underestimated the Soviets. They had underestimated the T-34. And now, as they prepared to dissect a captured example of this mysterious tank, they would discover that everything they believed about armored warfare was about to change. If you are fascinated by the hidden stories of the Second World War, subscribe to this channel and comment below where you are watching from. Your support helps bring more untold history to light. The story of German engineers testing the T-34 begins not in a laboratory, but on the battlefield, in the chaos and confusion of Operation Barbarossa's opening months. When German forces crossed into Soviet territory on June 22, 1941, they brought with them an unshakable confidence in their technological superiority. The Panzer III and Panzer IV had crushed Poland in weeks, humiliated France in 6, and driven the British from the continent. German tank doctrine emphasized precision engineering, crew comfort, and tactical flexibility. Their tanks featured sophisticated optics, reliable radios, and ergonomic turret designs that allowed commanders to coordinate complex battlefield maneuvers. The crews trained extensively, understanding their machines intimately, treating them almost as extensions of themselves. The Soviets, by contrast, were supposed to be backward. German intelligence had dismissed Red Army equipment as crude copies of Western designs, poorly manufactured and worse maintained. The purges of 1937 and 38 had gutted the Soviet officer corps, eliminating experienced leaders and replacing them with political appointees. Stalin's disastrous winter war against Finland had exposed shocking deficiencies in training, logistics, and equipment. Everything pointed to a swift victory. The Wehrmacht expected to reach Moscow before the autumn rains turned Russian roads to mud. They expected the Soviet Union to collapse like a house of cards, its military incapable of sustained resistance against modern combined arms warfare. Then they encountered the T-34. The first reports filtered back through German command channels in late June and early July, dismissed initially as exaggerations or misidentifications. Panzer crews described a medium tank with sloped armor that deflected their 37mm rounds like pebbles bouncing off a boulder. They spoke of a vehicle that moved through terrain where their own tanks became hopelessly stuck, that seemed immune to the standard anti-tank weapons that had proven so effective against every other opponent. The reports multiplied. From Army Group Center came accounts of T-34s absorbing multiple hits from Panzer IIIs at point-blank range, then pivoting their turrets and destroying their attackers with a single shot. From Army Group South came descriptions of Soviet counterattacks where T-34s rolled through German positions like steel juggernauts, impervious to everything but the heaviest artillery. General Heinz Guderian, perhaps the Wehrmacht's most experienced armor commander, confronted the T-34 problem directly in the autumn of 1941. His panzer forces had achieved remarkable penetrations into Soviet territory, but the appearance of T-34s in increasing numbers was changing the tactical calculus. In his memoirs, Guderian would later acknowledge that the T-34 represented a serious challenge, one that forced German planners to reconsider fundamental assumptions about tank design. The Soviet machine possessed advantages in firepower, protection, and mobility that German tanks could not match. Something had to be done. The solution, at least in the short term, was the 88mm flak gun, originally designed as an anti-aircraft weapon but pressed into service against Soviet armor when nothing else would work. These powerful guns could penetrate the T-34's armor at ranges exceeding 1,500 meters, giving German forces a desperately needed counter to the Soviet tank threat. But the 88 was a defensive weapon, heavy, difficult to move, and vulnerable to infantry attack. It could not restore the mobility that had defined German armored warfare. For that, the Wehrmacht needed new tanks, tanks designed specifically to counter the T-34. And to design those tanks, German engineers first needed to understand exactly what made the T-34 so effective. The captured T-34 arrived at the German proving grounds in late 1941, a battered example recovered from the battlefield after its crew had been neutralized, and the vehicle immobilized by damage to its running gear. German engineers approached the machine with a mixture of curiosity and skepticism, expecting to find crude Soviet workmanship and obvious design flaws that would explain away the battlefield reports. What they discovered instead would fundamentally alter their understanding of armored vehicle design. The first thing that struck the German evaluation team was the armor configuration. Every German tank of the period featured vertical or near-vertical armor plates, following the conventional wisdom that flat surfaces provided the best combination of protection and manufacturing simplicity. The T-34's hull, by contrast, featured dramatically sloped armor angled at approximately 45 degrees from vertical. This was not a new concept in absolute terms. Engineers understood that sloped armor could deflect incoming rounds and effectively increase protection without adding weight. But no one had applied the principle as aggressively as the Soviets. The German engineers began their calculations and quickly grasped the implications. The T-34's frontal hull armor was 45 millimeters thick, nominally inferior to the 50 millimeters of frontal protection on the Panzer III ESF-J. But because of the extreme angle, an incoming round striking the T-34's glacis had to penetrate through approximately 63 millimeters of effective armor, assuming the projectile did not simply ricochet off entirely. In practical terms, this meant that the T-34 offered protection comparable to tanks with much thicker and heavier armor plates, while maintaining a relatively light overall weight of around 26 tons. The design was elegant in its simplicity, achieving through geometry what German engineers had assumed required brute mass. The turret told a similar story. Cast rather than welded, it featured curved surfaces that deflected rounds in unpredictable directions, denying attackers the clean perpendicular impacts that maximized penetration. The casting process itself was cruder than German standards, with visible imperfections and inconsistent surface quality. But these cosmetic deficiencies did not compromise the fundamental protective value of the design. The turret worked, and it worked well enough to survive hits that would have destroyed contemporary German turrets. German engineers noted the construction quality with mixed assessments. The welding on the hull plates was rough by their standards, with visible seams and occasional gaps that would never have passed inspection at a German factory. The Americans, who later examined T-34s at the Aberdeen Proving Ground in 1942, made similar observations, criticizing the armor's build quality, particularly the plate joins and welds. Testing revealed that the Soviets used relatively soft steel combined with shallow surface tempering, a compromise that reduced manufacturing complexity at some cost to absolute hardness. But the German evaluators recognized something that pure quality metrics failed to capture. The T-34 was not designed to meet peacetime engineering standards. It was designed to be produced in massive quantities by a workforce that included hastily trained factory workers, women replacing men sent to the front, and evacuees from occupied territories working in relocated plants beyond the Ural Mountains. Every simplification in the manufacturing process, every corner cut in fit and finish, translated into additional tanks rolling off assembly lines. Each T-34 could be built in less than 2 weeks, a production tempo that German factories, with their emphasis on precision and quality, could not hope to match. The evaluation team turned their attention to the T-34's running gear And here they found perhaps the most significant explanation for the tank's battlefield performance. German tanks of the period used various suspension systems, generally involving small road wheels and relatively narrow tracks. These designs worked well on European roads and firm ground, but they struggled in the soft soils and extreme conditions of the Russian interior. The T-34 employed a suspension system derived from designs pioneered by the American inventor J. Walter Christie, featuring large road wheels mounted on long coil springs that provided exceptional shock absorption and ground clearance. The tracks themselves demanded particular attention. Each track was 550 millimeters wide, dramatically broader than the tracks on contemporary German tanks. This width spread the T-34's 26 tons across a larger surface area, reducing ground pressure to approximately 0.72 kilograms per square centimeter. The practical effect was transformative, where German tanks bogged down in mud, became stuck in snow, and struggled on soft ground. The T-34 glided through terrain that should have been impassable. The wide tracks distributed weight so effectively that the tank could traverse marshes, cross snow-covered fields, and navigate the notorious Rasputitsa, the Russian mud season that turned unpaved roads into bottomless quagmires twice each year. German engineers had encountered mobility problems throughout Operation Barbarossa, watching their tanks sink into terrain that Soviet vehicles crossed without difficulty. Now they understood why. The T-34's designers had anticipated the conditions their tank would face and engineered solutions from the outset. The wide tracks were not an afterthought or a field modification. They were fundamental to the vehicle's conception, reflecting a design philosophy that prioritized operational effectiveness over engineering elegance. The heart of the T-34 was its V2 diesel engine, a 12-cylinder power plant producing approximately 500 horsepower. German engineers examined this engine with particular interest because it represented a fundamental departure from their own design choices. Every mass-produced German tank of the Second World War used gasoline engines, following the conventional wisdom that petrol power plants offered superior power-to-weight ratios and easier maintenance. The Soviets had chosen differently, accepting the additional weight and complexity of diesel technology in exchange for specific operational advantages. The most obvious advantage was reduced fire risk. Gasoline is highly volatile, igniting readily when exposed to sparks or open flame. Diesel fuel is comparatively stable, requiring higher temperatures and pressures to combust. When a German tank took a penetrating hit, the fuel often ignited, turning the vehicle into an inferno that gave crews only seconds to escape. Soviet tankers faced the same dangers, but the T-34's diesel fuel provided a marginally greater chance of survival when the armor was breached. In the brutal calculus of armored warfare, even small improvements in crew survivability translated into experienced tankers living to fight another day. The diesel engine also offered superior fuel economy, extending the T-34's operational range and reducing the logistical burden of keeping tank units supplied. German forces in Russia struggled constantly with supply lines that stretched hundreds of kilometers across primitive road networks. Every additional kilometer of range meant fewer fuel convoys, less exposure to partisan attack, and greater operational flexibility for commanders planning deep penetrations into enemy territory. But the characteristic that most impressed German engineers during their winter evaluation was the diesel engine's cold weather performance. Gasoline engines in German tanks required extensive preparation before starting in sub-zero temperatures. Crews had to warm the engine block, preheat lubricants, and sometimes resort to lighting fires beneath the hull to prevent fuel lines from freezing. These procedures consumed time, attracted enemy attention, and often failed anyway, leaving vehicles stranded and vulnerable. The T-34's diesel engine could start reliably at temperatures that immobilized German equipment, Soviet engineers had designed the power plant specifically for winter operations, incorporating features that prevented fuel gelling, maintained lubricant viscosity, and ensured reliable ignition even in extreme cold. During the winter of 1941–42, when temperatures around Moscow dropped to minus 30 degrees Celsius and below, this advantage proved decisive. German panzer divisions lost significant portions of their strength, not to enemy action, but to cold weather that their vehicles simply could not handle. Soviet T-34 units continued operating, launching counterattacks against frozen German positions with tanks that started when needed and ran without constant mechanical attention. The German evaluation extended to the T-34's armament, centered on the 76mm F-34 gun that gave the tank its numeric designation. This weapon represented a significant upgrade over the original L-11 gun fitted to early production vehicles, offering higher muzzle velocity and improved penetration against armored targets. German engineers tested the gun's performance and found that it could penetrate the frontal armor of Panzer III and Panzer IV tanks at combat ranges, giving the T-34 a decisive advantage in tank-versus-tank engagements. The 76mm round combined acceptable performance against both armored vehicles and soft targets, making the T-34 a flexible battlefield asset capable of engaging diverse threats without requiring specialized ammunition or supporting weapon systems. The turret arrangement drew criticism from the German team, echoing observations made by other nations that examined captured T-34s. The original turret design accommodated only two crew members, the commander and the loader, forcing the commander to simultaneously direct the vehicle, identify targets, aim the main gun, and coordinate with other tanks in the unit. This arrangement overloaded the commander with responsibilities that German doctrine distributed among multiple crew members. German tank commanders could focus on tactical awareness and coordination, leaving gunnery to dedicated personnel. Soviet commanders had no such luxury, and their situational awareness suffered accordingly. The Americans who tested T-34s at Aberdeen made similar observations, noting that the turret was extremely cramped and questioning how Soviet tankers could fit inside while wearing winter sheepskin jackets. The electrical mechanism for rotating the turret drew particular criticism, with testers noting that the motor was weak, overloaded, and prone to sparking that burned out speed regulators and damaged cogwheel teeth. These deficiencies were real and significant, contributing to slower target acquisition and engagement compared to tanks with more sophisticated fire control systems. Yet German evaluators recognized that these shortcomings existed within a broader context. The T-34 was not designed for the kind of careful, coordinated engagements that German doctrine emphasized. It was designed for mass armored operations where overwhelming numbers compensated for individual crew limitations. A Soviet tank brigade operating 50 T-34s could afford slower engagement times and reduced situational awareness because sheer volume of fire and armored mass would carry the day. The design philosophy accepted individual weaknesses in exchange for aggregate strength, a trade-off that German engineers, trained to maximize performance of each individual vehicle, found difficult to fully appreciate. Take a moment to like this video if you are finding it informative, and share it with others who appreciate the deeper stories of military history. Your engagement helps this channel continue bringing these accounts to light. The German evaluation of the captured T-34 produced a comprehensive report that circulated through Wehrmacht technical channels in early 1942. The document acknowledged the T-34's strengths frankly, praising the sloped armor design, the wide tracks, and the diesel engine's cold weather reliability. It also cataloged weaknesses, including the cramped turret, the crude manufacturing quality, and the overloaded commander position. But the report's overall tone reflected grudging respect for design philosophy that had produced a genuinely formidable fighting vehicle through methods utterly different from German practice. The immediate question facing German planners was how to respond. Some advocated simply copying the T-34, arguing that the Soviet design offered the best available template for a medium tank suited to Eastern Front conditions. This approach had historical precedent. German forces routinely captured and reused Soviet equipment, pressing everything from rifles to artillery pieces into Wehrmacht service. Captured T-34s did see use by German units, though the practice remained limited due to spare parts difficulties and the risk of friendly fire from units that could not distinguish captured vehicles from enemy tanks. But direct copying faced significant obstacles. German industry was not configured to produce the T-34's components, and retooling factories for Soviet designs would disrupt existing production at exactly the moment when maximum output was needed. The T-34's manufacturing processes, while effective for Soviet conditions, did not align with German industrial practices. Perhaps most importantly, German engineers believed they could do better, taking the lessons learned from the T-34 and applying them within a framework that maintained German quality standards and doctrinal preferences. The result of this thinking was a new generation of German tanks designed specifically to counter and surpass the T-34. The Panther, designated Panzerkampfwagen 5, incorporated sloped armor directly inspired by Soviet designs while maintaining the crew comfort, optical quality, and fire control sophistication that characterized German armored vehicles. Its 75mm KBK 42 gun could penetrate T-34 armor at ranges exceeding 1,000 meters, restoring the engagement advantage that German tankers had lost. The Panther's suspension employed interleaved road wheels that provided excellent cross-country performance, though this system proved maintenance-intensive and vulnerable to track freezing in winter conditions. The Tiger Bauer, while not directly influenced by T-34 evaluation, represented another response to the changed conditions of armored warfare on the Eastern Front. Its 88mm gun could defeat any Soviet tank at extreme ranges, and its thick armor provided protection against virtually all Soviet anti-tank weapons then in service. The Tiger was a fearsome machine, but it was also heavy, expensive, and mechanically complex. Each Tiger consumed manufacturing resources that could have produced several Panzer IVs, and the vehicle's weight created logistical challenges that limited its operational flexibility. Neither the Panther nor the Tiger fully solved the problems that the T-34 had exposed. The Panther suffered from mechanical reliability issues throughout its service life, with early examples breaking down at alarming rates due to transmission and suspension failures. The Tiger's weight prevented it from crossing many bridges and limited the roads it could traverse without becoming stuck. Both vehicles required extensive maintenance from highly trained crews, and spare parts remained perpetually scarce as German industry struggled to meet the demands of a multi-front war. The fundamental lesson of the T-34, the value of simplicity and mass production over individual excellence, never fully penetrated German tank design philosophy. German engineers continued to pursue technological sophistication, creating vehicles that were individually superior but collectively insufficient. The numbers told the story with brutal clarity. The Soviet Union produced over 80,000 T-34s during the Second World War. Germany produced fewer than 6,000 Panthers and approximately 1,350 Tigers. In the arithmetic of industrial warfare, quality could not compensate for such overwhelming quantity. The winter of 1941-42 marked the first great crisis of the German invasion, and the T-34 played a central role in Soviet survival. When German forces reached the outskirts of Moscow in December, they had outrun their supply lines, exhausted their troops, and pushed their equipment beyond operational limits. The temperature dropped to levels that German planners had not anticipated, immobilizing vehicles, freezing weapons, and causing thousands of casualties from exposure. In these conditions, Soviet forces launched a massive counteroffensive that drove the Wehrmacht back from the capital and shattered the myth of German invincibility. T-34 battalions spearheaded the December counterattacks, exploiting their cold weather advantages to achieve tactical surprise against immobilized German positions. Soviet commanders had learned from the disasters of the summer and autumn, concentrating their armor for decisive strikes rather than dispersing it in penny packet deployments that German anti-tank units could defeat in detail. The T-34's ability to operate when German tanks could not provided crucial windows of opportunity, allowing Soviet forces to achieve local superiority and exploit breakthroughs before the enemy could respond. German soldiers who survived that winter carried memories of T-34s emerging from snowstorms, their white camouflaged hulls nearly invisible against the frozen landscape, their engines running while German vehicles sat silent and frozen. The psychological impact complemented the tactical effect, creating a mystique around the Soviet tank that persisted throughout the war. German tankers developed a healthy respect for the T-34, recognizing it as a dangerous opponent that demanded caution and careful tactics to defeat. The story of the T-34's development provides essential context for understanding why the tank performed so well in conditions that defeated German engineering. Soviet designers had begun work on what would become the T-34 in the mid-1930s, building on experience with the BT series of fast tanks that themselves derived from Christie's American designs. The chief designer, Mikhail Koshkin, led a team at the Kharkov locomotive factory that understood their tank would need to operate across the vast distances and extreme climates of the Soviet Union. The design requirements specified a tank capable of functioning in temperatures ranging from minus 40 degrees to plus 100 degrees Fahrenheit, an operational envelope far wider than anything German planners considered. Soviet engineers knew their tank would face mud seasons that turned roads to soup, winters that froze lubricants solid, and summers that overheated cooling systems. Every design decision reflected these anticipated conditions, from the wide tracks to the diesel engine to the simplified manufacturing processes that would allow production to continue even if skilled workers were unavailable. Koshkin drove the T-34 program with passionate intensity, personally supervising prototype construction and testing. In March 1940, he accompanied two prototype T-34s on an extraordinary journey from Kharkov to Moscow and back, a round trip of nearly 2,000 kilometers conducted in harsh winter conditions over poor roads. The journey was intended to demonstrate the tank's reliability and earn official approval for mass production, but it took a terrible toll on Koshkin's health. He contracted pneumonia during the grueling trip and never fully recovered, dying in September 1940 before the first T-34 saw combat against German forces. The tank that Koshkin sacrificed his health to create entered production in 1940, initially at the Kharkov factory, but soon spreading to additional facilities as the Soviet government recognized the T-34's potential. When German forces invaded in June 1941, approximately 1,200 T-34s had been produced, though many were dispersed across various units, and some suffered from the mechanical teething problems common to newly introduced equipment. The initial encounters between T-34s and German tanks stunned both sides, revealing to the Soviets that they possessed a genuinely superior weapon and confronting the Germans with an opponent their standard anti-tank arsenal could not defeat. The evacuation of Soviet industry during the autumn of 1941 represented one of the most remarkable logistical achievements of the war, and the T-34 figured prominently in the effort. As German forces advanced toward major industrial centers, the Soviet government ordered the wholesale relocation of factories to sites east of the Ural Mountains, beyond the reach of enemy ground forces. The Kharkov locomotive factory, birthplace of the T-34, was disassembled and transported by rail to Nizhny Tagil, where it resumed production as the Ural Tank Factory. Other facilities scattered across the Soviet Union tooled up for T-34 manufacturing, creating a distributed production network that proved impossible to destroy through bombing or ground attack. The simplified design philosophy that German engineers noted during their evaluation paid dividends during this desperate period. T-34s could be produced by workers with minimal training, using manufacturing techniques that did not require precision machinery or specialized skills. Quality suffered, certainly. T-34s built during the crisis months of late 1941 and early 1942 often featured rough welding, inconsistent armor quality, and mechanical systems that failed under hard use. But they could be built, and they were built in numbers that astonished German intelligence analysts who had predicted Soviet industrial collapse. The factories kept running through the winter of 1941 to 42, producing tanks that rolled directly from assembly lines to the front, sometimes with their factory paint still wet. Crews trained on the vehicles during the journey to combat units, learning the basics of operation during rail transport and road marches. This was not the methodical German approach of thorough training and careful preparation. It was industrial warfare at its most brutal and direct, feeding men and machines into a meat grinder and trusting that volume would compensate for individual readiness. German engineers who examined captured T-34s during this period noted the declining quality compared to earlier production vehicles. Armor plates showed inconsistent hardness. Welding seams revealed gaps and imperfections. Components that should have been machined to precise tolerances were instead rough-fitted and adjusted in the field. Yet the tanks kept coming in numbers that made individual quality concerns increasingly irrelevant. By mid-1942, T-34 production had recovered from the disruption of industrial evacuation and was accelerating toward peaks that would eventually reach over 1,000 vehicles per month. The T-34 underwent continuous improvement throughout the war, addressing weaknesses identified through combat experience and technical evaluation. The original 76mm gun gave way to improved versions with better penetration and muzzle velocity. The troublesome two-man turret was eventually replaced by a larger three-man design that freed commanders from gunnery duties and improved tactical effectiveness. The T-34-85 variant, introduced in 1944, featured an 85mm gun capable of engaging Panthers and Tigers at reasonable ranges, restoring competitive parity with the latest German armor. These improvements reflected a Soviet willingness to adapt the T-34 design while maintaining its fundamental characteristics. The sloped armor remained. The wide tracks remained. The diesel engine remained. The simplified manufacturing processes remained. Each upgrade added capability without sacrificing the core advantages that had made the T-34 effective in the first place. German engineers, by contrast, tended toward clean-sheet designs that incorporated new features at the cost of proven reliability. The Panther was better than the T-34 in many respects, but it was also a new design with new problems, while the T-34-85 was a refined version of a proven platform. The human element of T-34 operations deserves attention alongside the technical analysis. Soviet tank crews faced conditions that tested the limits of human endurance, fighting in vehicles that prioritized functionality over comfort. The cramped interiors, criticized by German and American evaluators, forced tankers to operate in positions that caused chronic back problems and fatigue. The noise levels from the engine and transmission made communication difficult, forcing crews to develop hand signals and physical cues to coordinate their actions. The lack of adequate ventilation meant that crew members breathed fumes from the gun and engine during combat, causing headaches and nausea that degraded performance during extended engagements. Yet Soviet crews learned to operate their tanks effectively, developing techniques and tactics suited to the T-34's characteristics. They exploited the vehicle's speed and mobility to close with German tanks quickly, negating the range advantage of superior German optics and guns. They learned to work around the limited gun depression by positioning their tanks on terrain features that compensated for mechanical limitations. They developed field expedients for maintenance challenges, keeping vehicles operational through improvisation and determination when proper spare parts were unavailable. The production tempo of the Soviet tank industry meant that crews often received vehicles with different characteristics as manufacturing changes were implemented without standardization across production batches. A T-34 built in January might differ significantly from one built in March with different armor composition, engine variants, or interior arrangements. Crews had to adapt to these variations, maintaining proficiency across multiple vehicle configurations rather than specializing on a single, standardized type. This flexibility became an asset as the war progressed, allowing Soviet tank units to absorb replacement vehicles quickly without extended retraining periods. German responses to the T-34 evolved throughout the war as commanders developed tactics to counter the Soviet tanks' advantages. The preferred approach was engagement at long range, exploiting the superior optics and gun accuracy of German tanks to destroy T-34s before they could close to effective fighting distance. Panther crews trained to engage T-34s at ranges exceeding 1,000 meters, where their 75mm guns could penetrate Soviet armor, while the T-34's lower velocity gun struggled to achieve reciprocal penetration. Tiger crews operated at even greater ranges, using their 88mm guns to pick off T-34s at distances where the Soviet tanks could barely identify their attackers. Anti-tank tactics also evolved, with German forces deploying dedicated tank destroyer units equipped with powerful guns mounted on modified tank chassis. The Jagdpanther and Jagdtiger represented the apex of this development, mounting guns capable of defeating any Soviet tank at extreme ranges. But these vehicles, like the tanks they supported, were expensive, complex, and available only in limited numbers. The fundamental problem remained. Germany could not produce enough vehicles to match Soviet numbers, regardless of the qualitative advantages each individual machine possessed. The strategic implications of the T-34's success extended beyond the Eastern Front, influencing tank design worldwide for decades after the war's conclusion. Engineers who examined captured T-34s recognized that the Soviets had achieved something remarkable, creating a weapon that was simultaneously simple enough for mass production and effective enough for frontline combat. The sloped armor concept became universal in post-war tank design, appearing on American, British, French, and German vehicles that followed the T-34's lead. The emphasis on diesel engines spread as fuel efficiency and reduced fire risk gained recognition as operational requirements rather than mere preferences. The British evaluation of T-34s captured and transferred by Soviet allies reinforced the conclusions German engineers had reached. Testing in Britain confirmed the tank's armor effectiveness, cross-country mobility, and cold weather reliability. British engineers noted that the T-34 could start reliably at low temperatures and maintain operation through conditions that would immobilize their own tanks. The Christie-derived suspension provided excellent shock absorption, reducing crew fatigue and maintaining gun stability during high-speed maneuvers. Track pins showed remarkable resilience, resisting the failures that plagued British tanks operating in harsh terrain. The British report praised the Soviet approach of prioritizing simplicity, stout armor, and wide tracks over refinement and crew comfort. This was a tank designed for mass production and harsh conditions, not for the parade ground or the inspection depot. The T-34 demonstrated that a tank could be both highly survivable and simple enough for mass production, proving that slope could substitute for thickness without compromising protection and showing that surplus power enabled tactical flexibility. These lessons directly shaped the next generation of British designs, influencing the development of post-war tanks that incorporated T-34 inspired features within a British engineering framework. American testing at Aberdeen Proving Ground provided additional technical data, though the American report was more critical than British or German assessments. The Americans noted problems with armor quality, air filtration, and the Christie suspension, which they had tested and rejected years earlier. They criticized the manufacturing quality and identified design features that they considered obsolete by American standards. Yet even the Aberdeen report acknowledged the T-34's effectiveness within its operational context, recognizing that the Soviets had made deliberate trade-offs that prioritized mass production capability over individual vehicle refinement. The question of whether to copy the T-34 directly arose in multiple nations during and after the war. Germany considered and rejected the option, as noted earlier, preferring to develop indigenous designs that incorporated T-34 lessons within German engineering traditions. The British reached similar conclusions, recognizing that direct imitation would disrupt existing production and create logistics complications. Instead, both nations incorporated T-34 features into new designs developed from domestic technological bases, acknowledging Soviet innovations while maintaining national approaches to armored vehicle design. The post-war period saw T-34s continue in service with numerous nations, as the Soviet Union exported the tanks to allies and client states around the world. Variants of the T-34 saw combat in Korea, the Middle East, Africa, and Southeast Asia, facing American, Israeli, and other opponents decades after the type first entered production. These extended service careers confirmed the fundamental soundness of the basic design, demonstrating that a tank conceived in the 1930s could remain operationally relevant into the 1980s under appropriate circumstances. The legacy of German engineers praising the T-34's winter simplicity extends beyond technical specifications to encompass broader lessons about industrial warfare and design philosophy. The Germans approached tank design as an engineering challenge, seeking optimal solutions through sophisticated technology and precision manufacturing. The Soviets approached tank design as a production challenge, seeking adequate solutions that could be manufactured in overwhelming numbers. Both approaches had merits and both faced limitations, but in the specific context of the Eastern Front, with its vast distances, extreme conditions, and massive casualties, the Soviet approach proved more effective. The German engineers who tested that captured T-34 in 1941 came away with uncomfortable insights about the nature of modern warfare. Technical excellence, they discovered, was not sufficient for victory. A tank that started reliably in winter outperformed a tank that could not start at all, regardless of the latter's theoretical capabilities. A tank that could be produced in thousands outmatched a tank produced in hundreds, even if each individual vehicle was superior. A tank designed for the conditions it would actually face defeated a tank designed for ideal conditions that existed only in testing facilities and training grounds. These lessons resonated through German military planning for the remainder of the war, though they were never fully implemented. The Wehrmacht continued to develop sophisticated, complex weapon systems that demanded extensive training, careful maintenance, and elaborate supply chains. The Tiger II, the Jagdtiger, the Maus, each represented further elaboration of the German preference for quality over quantity, sophistication over simplicity. Each failed to reverse the fundamental trends that the T-34 exemplified, the triumph of industrial capacity and operational pragmatism over engineering excellence and tactical refinement. The Soviet Union understood from the beginning that the coming war would be won or lost in the factories as much as on the battlefields. The T-34 was designed not just to fight German tanks, but to be produced in numbers that German industry could not match. Every design decision reflected this priority, accepting compromises in crew comfort, manufacturing quality, and individual vehicle performance in exchange for production numbers that would overwhelm the enemy through sheer mass. This was not a failure of Soviet engineering capability, but a deliberate strategic choice, validated by the outcome of the conflict. German engineers who examined the T-34 recognized its simplicity, but initially misunderstood its significance. They saw crude manufacturing and assumed it reflected Soviet inability to achieve German standards. They noted design compromises and interpreted them as engineering failures rather than conscious trade-offs. Only gradually, as T-34 numbers multiplied and German losses mounted, did the full implications become clear. The Soviets had not failed to build sophisticated tanks. They had chosen to build simple tanks in quantities that made sophistication irrelevant. The winter simplicity that German engineers praised during their T-34 evaluation represented something deeper than cold weather engineering. It reflected an entire approach to industrial warfare that prioritized operational effectiveness over theoretical perfection. The T-34 started when German tanks did not, moved where German tanks could not, and fought in numbers German industry could not match. These advantages did not require advanced technology or precision manufacturing. They required clear thinking about operational requirements and honest assessment of manufacturing capabilities. If this deep dive into the T-34's history has given you new perspective on armored warfare, please subscribe and hit the notification bell to catch future episodes exploring the hidden stories of military history. Your support makes these detailed examinations possible. The T-34's influence on tank design continues to resonate in the modern era, with contemporary armored vehicles still reflecting lessons learned from the Soviet approach. The emphasis on protection through sloped armor rather than brute thickness became universal doctrine, appearing on every major tank design since the Second World War. The preference for diesel engines over gasoline power plants similarly achieved consensus, as reduced fire risk and improved fuel economy proved their value across multiple conflicts and operational environments. The broad tracks that gave the T-34 its legendary mobility inspired similar features on tanks designed for operations in soft terrain, from the Russian steppes to the jungles of Southeast Asia. The human stories behind the T-34's development and deployment deserve remembrance alongside the technical achievements. Mikhail Koshkin, who drove himself to death proving his tank's reliability, never saw the weapon he created help save his country from destruction. The factory workers who maintained production through the crisis of 1941, often working in unheated facilities with inadequate food and equipment, contributed as much to Soviet survival as any general or marshal. The tank crews who fought in T-34s, accepting the cramped conditions and mechanical limitations to defend their homeland, demonstrated courage that no engineering specification can capture. German engineers who tested that captured T-34 contributed their own chapter to the story, providing honest assessments that helped shape responses to the Soviet tank threat. Their willingness to acknowledge enemy achievements, even when those achievements challenged German assumptions about technological superiority, reflected professional integrity that transcended national loyalties. The reports they produced circulated through military establishments worldwide, influencing tank design in nations that had never seen a T-34 firsthand. Their observations about winter simplicity, about wide tracks and diesel engines and sloped armor entered the common knowledge of armored warfare and remain relevant today. The final lesson of the T-34 concerns the relationship between technology and strategy. The tank that won the Eastern Front was not the most advanced or sophisticated vehicle on the battlefield. It was not the fastest, the most heavily armored, or the most powerfully armed. But it was available in numbers that compensated for individual limitations produced by an industrial base that could replace losses faster than the enemy could inflict them, and designed for the specific conditions of the war it was built to fight. German tanks were engineering marvels. Soviet tanks won the war. The difference illuminates fundamental truths about industrial conflict that remain relevant in any era. When German engineers gathered around that captured T-34 in the winter of 1941, they confronted a machine that challenged everything they believed about proper tank design. The crude welds, the cramped turret, the rough casting marks, all suggested Soviet inferiority by German standards, but the tank started when their tanks would not. It moved through terrain that trapped their tanks. It absorbed hits that destroyed their tanks. Technical standards meant nothing against these operational realities. The T-34 worked, and in the brutal mathematics of industrial warfare, working was all that mattered. The phrase, "winter simplicity," captures something essential about the T-34's character and the philosophy it embodied. Soviet engineers did not attempt to create the perfect tank. They created a tank that was good enough for the job it needed to do, simple enough to be produced in massive quantities, and robust enough to function in conditions that defeated more sophisticated designs. This was not a failure of ambition, but an achievement of pragmatism, recognizing that the war would be won by the side that could field more operational tanks, not by the side that could build better theoretical machines. The story of German engineers testing a captured T-34 and praising its winter simplicity encapsulates one of the great technological competitions of the Second World War. Two industrial nations, each representing different approaches to engineering and manufacturing, produced armored vehicles that reflected their national characteristics. German tanks embodied precision, sophistication, and technological ambition. Soviet tanks embodied simplicity, pragmatism, and industrial realism. When these philosophies collided on the frozen steppes of Russia, the outcome was decided not by which approach was theoretically superior, but by which approach better matched the actual conditions of the conflict. The T-34 won that competition not because it was the better tank in absolute terms, but because it was the better tank for the war that actually had to be fought in the cold, in the mud, in numbers beyond German capacity to match or counter. The frozen engine refused to turn. German mechanics gathered around a captured Panzer III somewhere on the outskirts of Moscow in December 1941, pouring boiling water over the transmission, lighting fires beneath the hull, cursing the cold that had turned their precision-engineered machine into a frozen monument to failure. 50 meters away, a Soviet T-34 roared to life on the first attempt.